While some may argue that exploring science concepts in the foundation year of education is utterly futile, I beg to differ on a momentous scale. A key element of the Council of Australian Government's Early Years Learning Framework is learning through play. The Australian Curriculum Science allows exactly this, though it is not playing in the traditional sense. It's about engaging and fostering enjoyment in the world around the students and working scientifically to make sense of the many phenomena of life. Put simply, this is the very essence of an authentic learning situation, connecting the real world of the students' own lives to scientific concepts. Using the foundation year level example, the primary connections Weather in My World unit provides the opportunity for students to consider, explore and investigate the effects of weather. This unit focuses on the Earth and Space Sciences curriculum element of how daily and seasonal changes in our environment affect everyday life. By utilising an inquiry-based approach to science of engagement, exploration, explanation, elaboration and evaluation, the implementation of this unit of study is focused on developing the necessary knowledge, understanding and skills required for lifelong learning associated with science education. Such an approach revolves around examining why things are the way they are, like why is the sky blue? And it is these questions that form the very basis of science. Science investigations, however, examine these ponderings, societal issues and world phenomena through the eyes of scientific concepts, and it is here that the notion of working scientifically comes into play. This is described by Feasey in saying that both thinking and working scientifically are integrated by bringing together knowledge and understanding of science concepts and the application of necessary skills to answer a scientific question or solve a problem. The investigative approach, in alignment with the concept of working scientifically, is governed quite immensely by the ideas put forward in the theory of socio-cultural constructivism. This model per se can be broken down into two components of the work of prominent educational philosophers and theorists Piaget and Vygotsky. Constructivism is essentially the theory that knowledge and meaning is constructed from experiences, an idea put forward by Piaget that dictates that all learning revolves around the significant role that experiences or connections with the adjoining atmosphere play in student education. This concept is further extended in the context of the socio-cultural world of human development, with the perspective of Vygotsky, who rejected the assumption made by Piaget that it was possible to separate learning from its social context. Vygotsky posed the theory of the zone of proximal development, of the optimal point for learning new skills, just beyond the individual's current level of independent capability to a level that is possible with targeted assistance. This point, realistically, is the next logical step for ongoing development. With this in mind, the socio-cultural constructivist approach emerged with the conclusions that investigative learning fosters a more open and/or guided rather than closed nature, and is congruent with the optimal learning point of the zone of proximal development. It takes the persona of a classroom that sees students at the centre of their science learning, being actively involved in their own processes of ongoing learning and natural curiosity. Now, it is this investigative approach based on socio-cultural constructivist learning theory, language, and teacher scaffolding that facilitates lifelong learning and results in a broadened understanding of the relationship between science and the individual worlds of each and every student. Harlan, a prominent science education researcher, argues this to be the basis of an emerging and more effective pedagogy in science education. Within this element of socio-cultural constructivism is innately the pertinence of the cross-curriculum priority of Aboriginal and Torres Strait Islander histories and cultures. This component of 21st century learning relates heavily to the socio-cultural understanding that is required for successful participation in Australia's modern society. The appreciation of Aboriginal and Torres Strait Islander histories and cultures and the incorporation of the perspective of the Indigenous Australians can provide an immensely rich and greater understanding of various science education topics. Looking specifically at the aforementioned unit of study, there is a plethora of opportunities to explore the different ways of tracking, reading and understanding weather between Western science ways and that of traditional Aboriginal and Torres Strait Islander science knowledge and traditions. An example of this could be exploring how the weather affects our behaviour and contextualising this by linking it to real-life practices, such as that of checking the weather before an event, or by relating that as seasons change, we make slight modifications to the way we live. Then comparing this understanding to that of Aboriginal and Torres Strait Islander concepts of weather, time and seasons, and how they utilise patterns in weather to track the cycles of various flora and fauna. It is noted in many publications, such as The Shape of the Australian Curriculum and Melbourne Declaration, that it is increasingly important for Aboriginal and Torres Strait Islander people to be represented in all learning areas to demonstrate a collective understanding and appreciation of the diversity of identities and cultures of Australia. Doing so has been linked to better learning outcomes for Indigenous students and building self-esteem. Moreover, the inclusion of Indigenous perspectives reflects the values of 21st century education and promotes the engagement of all students in respect, reconciliation, and recognition of the world's oldest continuous living culture. Linking to this is also the concept of sustainability, as this was at the heart of Aboriginal and Torres Strait Islander people's lives in living with the land as opposed to off the land. This could provide opportunities to work with local Indigenous communities in learning about sustainable practices, with Cliff Cobbo of the Caring for Country program noting that Australia can draw on some of our practice through our traditional knowledge of the land. According to the Australian curriculum, sustainability education enables individuals and communities to reflect on ways of interpreting and engaging with the world. It is clear that this one mere foundation unit of Earth and space science provides a myriad of invaluable learning opportunities for the young students of today. Through an investigative socio-cultural constructivist approach, their lifelong learning journey begins of working scientifically to make sense of the world. Sustainability and Aboriginal and Torres Strait Islander perspectives are an important aspect in this learning journey, as they provide a contextual base of which authentic learning occurs, and knowledge, understanding and skills can be applied to real-life circumstances. Science education goes beyond just factual knowledge. It's about developing the skills, understandings and values that are essential for learners of the 21st century to draw evidence-based conclusions about societal science issues.